Hi there. In this video, we're going to continue our apportionment example, and we're going to learn about the Hill-Huntington method. Now, this is the method that's actually used today in the United States. There are also other methods, but we're skipping over some of them, and Hill-Huntington is the one that we're still using. So we have our 4 campuses and our FTEs and our 45 math instructor positions. And like we said before, the first 2 steps are exactly the same. So I'll just keep writing 23,231 divided by 45 positions, full-time positions, is 516.24. Okay, and then to get our standard quota, we're dividing by 516.24. We're dividing every campus FTE by the divisor. And this is what we got: 17.18, 9.38, 13.17, and 5.27. Okay, so that's steps 1 and 2. Now let's go down to Hill-Huntington, which was first used in 1941 all the way until today. So this was a group of mathematicians that sort of formed this method. Instead of rounding using 0.5 or higher, use the geometric mean, which is the square root of x times x plus 1, to round the initial number. Then raise or lower the divisor if needed, so there are no leftover seats. Okay, what are we talking about with this geometric mean? Let me show you. Let's write out the geometric means. I'm going to make a column for that. Okay, so now this number, if we cut off the decimal, is 17. So we're going to multiply 17, square root of 17 times 1 higher, which is 18. So that's the x. The x is the number cut off, and the x plus 1 is 1 higher. Now it just so happens that this decimal was 18. That has nothing to do. That's just a coincidence. So let me show you the next one, and then we'll calculate all these. So this quota cut off is 9. So our geometric mean will be the square root of 9 times 10. This one is 13, so this will be 13 times 14. And this one is 5, so this will be the square root of 5 times 6. Okay, now what you're going to see is this will give us a number between 17 and 18, between 9 and 10, between 13 and 14, between 5 and 6. And what we're going to do is use that number for rounding instead of 0.5. So let's calculate these, and then I'll show you how we're going to do this. So I need to find my square root button, which in my case is second square root. 17 times 18. And if you have a calculator like mine that's designed to give you an exact answer, you might have a decimal key, like this is the button on this calculator that changes from exact to a decimal. So if I push that, I get a decimal value. If you have a TI, these do that too, so you have to do second and then enter sign, which has the approximately equal symbol on it. If you have another one, you might have like a fraction decimal key like that, something that looks like that. Okay, so this comes out to 17.49. So all these are going to be around 0.5, but maybe slightly less, okay? So now let's do second square root, 9 times 10. Decimal button, 9.49. Okay, keep going. Second square root, 13 times 14. 13.49. And second square root, 5 times 6. Oops, don't need a parenthesis there. 5.48. Okay, so you might be wondering, why is this so complicated? The reason is some people felt that the smaller states were a little disadvantaged with Webster's method and also all the other ones. And the reason is, with the rounding, the bigger states would tend to get bumped up first. So what this does is, instead of using 0.5 to round, you can see most of these are 0.49, but the smallest campus, Southeast, is a little bit less. So what that's saying is, each quota we compare to the geometric mean, and if it's the same or higher as this geometric mean, we round it up. So we're using this as a rounding tool instead of 0.5. Okay, so we're going to say use for rounding instead of 0.5. Okay, 0.5 is called the arithmetic mean. It's the average between the two numbers. This is a different way of finding a number between the two numbers, the geometric mean. Okay, so now let's compare. Get a different color. We're going to compare 0.18 to 0.49. And is it higher? No. So this is going to stay 17. Now we're going to compare 0.38 to 0.49. This is not as big or larger, so we don't get to round up. So that's going to stay at 9. Compare 0.17 to 0.49. This is not as big as that, so we stay down at 13. And we compare 0.27 to 0.48. Not high enough, so we still are staying down at 5. Okay, so we know from before this is still 44. Okay, so we've used our different rounding rule, happened to get the same result so far, but now we lower the divisor just like Jefferson and Webster's method. Okay, so a lot of these methods have things in common. Okay, so Hill-Huntington says, instead of rounding using 0.5, use the geometric mean, so we did that. Then raise or lower the divisor so there are no leftover seats. Same thing as far as raising and lowering as Webster's method. So we did not bump any of these up, so we need to lower our divisor. So let me write this down again. If you have too few, lower the divisor. And if you have too many, you raise the divisor. A similar thing could happen where if 2 or 3 of these rounded up, we would have too many. And so then we would need to raise the divisor. But we are, in this case, still too low. So we're going to lower the divisor. So I'm going to try 510. These tend to work out similar to Webster's. So I'm going to try what I tried with Webster. And let's do our division again. So we go back to the beginning. 8871 divided by 510 is 17.39. 4841 divided by 510 is 9.49. Yes, remember that happened in Webster's method. We got 9.49. Now this is going to round up because we hit the geometric mean. Let's keep going. 6797 divided by 510 was 13.33. 2722 divided by 510 is 5.34. Okay, so now we compare, now we're over here, we're comparing these decimals to these geometric means. Okay, if our quota is this or higher, we bump it up. So this one stays down, 17. 9.49, now we matched our geometric mean, so that's our new rounding rule. So this one goes up to 10. 13.33 is not as high as 13.49, so that stays 13. 5.34 also stays 5 because it does not meet 5.48. It doesn't round up. 5. And that should be 45. Let's double check. 17 plus 10 plus 13 plus 5 is 45. So that is our final apportionment. Again, this one takes a lot of patience. Jefferson, Webster, and Hill-Huntington take a lot of patience and a lot of paper. So write out your steps really clearly so you know what divisor you used. So then you can figure out if you need to go lower or higher, and hang in there, keep working on it until you get the exact number. Okay, so that is all 4 methods, and thanks for watching, and I'll see you in the next video.